Chalo. Now let's start base system. So what is base system? What actually is base system? In base system, what happens? Every time what we see is base 10. Okay, the system that we see is base 10, right? So what is base 10? See, it is very simple. There are three models which we refer to as LCM models. We'll discuss it. Don't worry. Just leave it as of now. So what happens is in base system. Suppose we are taking base 10, right? So in base 10, what will happen? We will have digits from 0, 1, 2, 3, 4 till 9. So these will be the 10 digits. Okay. This is known as base 10. What is base 2? How many digits will be there? 0 and 1. This is base 2. Base 5, how many digits will be there? 0 till 4. Base 6, what will happen? 0 till 5. So if you want to write the numbers, first number will be 0, 1, 2, 3, 4, 5. Then 1, 0. Now related. See, when we deal with base system, I always want you guys to relate it with a number system or normal system of base 10. That is when you can capture these things really easily. In normal system, what happens? 1, 2, 3, 4, 5, 6, 7, 8, 9. After this, what will I get? 1, 0, 1 and 0, right? 1, 1, this, because now this becomes my first digit and every other digit will be repeated. Similar thing is happening here. This becomes my first digit. Every other digit is getting repeated one by one. Again, 2 becomes my first digit. Every other digit is getting repeated one by one. Okay. Just related to base 10. In hexadecimal, what happens? In hexadecimal, we have 0 to 15. That is 16 numbers in total. So what are these 16 numbers? 0 to 9, followed by A, B, C, D, and so on. Okay. So this is a very basic thing. Any doubt in this? What is base 10? What is base 2? What is base 6? What is hexadecimal? These are the very basic things. Other basic things I will just cover quickly. Suppose you want to convert any base to base 10. How you can do it? Suppose this number is written 1, 2, 3, 4, 5 in base 8. Okay. Sashank is asking a doubt that what can be the maximum number in base 6. Can you tell me what can be the maximum number in base 6? Is there any limit to the maximum number in base 6? No, na? What about 5, 5, 5, 5, 5, 5, 5, 5, 5, 5 till infinity? There is no limit, right? In our number system also there is no limit. Yeah, we have to specify the number of digits. Exactly. Okay. Anyways, so suppose this number is in base 8. So how to convert it to base 10, right? I can write this. If I want to convert it to base 10, I can simply break this number and write it, right? Like 1 into 8 to the power 0, 8 to the power 1. I can write it in base 10 in this fashion, this simple number. 10 to the power 4, 2 into 10 cube, 3 into 10 square. We have seen this earlier. Simply, you have to write it in 1 into 8 to the power 4 plus this 2 into 8 cube plus 3 into 8 square and so on. And this will get converted to base 10. Very simple, right? What about conversion to base n from base 10? If there is any other base and you want to convert it to base 10. See, these are very basic things. These things won't be asked. You just have to remember this. Nothing yet. Okay? These are the very basic things. Nice one, man. Okay, fine. See, Arpit, look here. Let's take another number. Let's take a number 23571. Okay, Arpit? Let's say this number is in base 7. I want to convert it to base 10. Right? So how can I do this? 2 into, see, okay, leave this number also. First, let's check 123. Can I write 123 as 1 into 10 square plus 2 into 10 plus 3? Can I do this, Arpit? A simple number in base 10, 123. So that's what I'm doing here. 2, see, 1, 2, 3, 4, 5 was there. So 1 into 8 to the power 4 plus 2 into 8 cube and so on. Clear? Arpit? And why we are getting this converting to getting converted to base 10? Because again, you by doing this, you will involve each and every decimal number from 1 to 0 to 9. Okay, so hence we will convert it to base 10. Also, let me convert from any base n to base n from base 10. Suppose I want to convert 1, 2, 3, 4, 5. This is in base 10, and I want to convert it to base 6. How can I do it? What is the basic funda of base 6? That numbers can be from 0 to 5. This is the basic funda, right? So if I'm having 1, 2, 3, 4, 5, I will just keep on dividing it by 6. Okay. If I'm having this number, what I will do, I will just keep on dividing it by 6 and I will get the remainders. So in those remainders, the numbers will be from 0 to 5 only, right? So what you have to do, just divide it by 6. Clear? So you will get the remainder as 3. Then again divide this by 6. You will get the remainder as 5. Then again divided by 6. You will get the remainder as 0. Again divided by 6 and so on. Okay. I think this is clear. Any doubts still now? That what we are doing, we are just dividing it by 6 so that we can get remainders. Each and every value will be between 0 to 5 in this case, right? We'll get 4, 6 ones are 6, remainder is 2, 6 zeros are 0, remainder is 1. So what will be your number? Your number will be 124053. This will be your number in base 6. And this is also the reason that you can multiply it by 6 to the power 0, 1, 2, 3, 4, 6 to the power 5 to convert it into base 10. Because what am I doing? From base 10 to base 6, I'm just dividing it by 666. And I'm taking the remainders. Why I'm taking the remainders? Because I want to convert into some system that is having only 0 to 5 as the numbers. Okay. Okay, Shweta, let's take it a bit slow. Okay, cool. Shweta, koi doubt abhi tak? Any doubt still now in this part? ये नहीं समझ में आया? Okay, let's take a small number. Till the end, we keep on dividing. Let's take a number 1, 2, 3, 4. Okay, small number. I want, or okay, let me take a smaller number for your reference, 123 only. This is in base 6. I want to convert it into base 10. Okay, but this is in base 10. I want to convert it into base 6. So what can I do? I have to divide it by 6, right? Yeah, write the remainders from the bottom. Why from the bottom, Shweta? Because we have to go it in reverse manner. Okay, 6 to the power 0, 1, 2, 3, 4, and so on. So this will be divisible 20 times. Shweta and Arpit, remainder will be 3. This will be divisible 3 times, remainder will be 2. This will be divisible 0 times, remainder will be 3. Okay, so what is the remainder? 323. Clear? Now is it clear? So this is in base 6. Converting 123 to base 6. What's the doubt, Hassan? Tell me. I'm just dividing it and writing the remainder. Dividing it, writing the remainder. Dividing it, writing the remainder. Why I am doing? Okay, cool. So this is in base 6. And if I want to convert this to base 10, then what you will do? Because I have divided it by 6 continuously. That is why 3 into, what you will do? 6 square plus 2 into 6 plus 3. This will be your answer. Again, you will get 123. I hope this is clear now. Okay. Hello. So yeah, now let's do the basic arithmetic of this. How do you add 1, 2, 3, 4 with 5, 6, 7, 8? What do you do? If you want to add these two numbers, how you add this? In base 10, I'm asking you guys. What is 8 plus 4? 12. You give one carryover and write 2 here. Can I ask why? Why you are giving one carryover? Well, this you might have seen in class 1 or class 2, and there you would have, the teacher would have told you just give one carryover. But why are you giving one carryover? Can anyone tell me the reason for it? Okay, base 10. So what happens if base is 10? Yeah, we are getting an excess of 10. Exactly. So what is 8 plus 4? 12. But my base is 10, right? I can only have digits from 0 to 9. That is why what I do, I give it this carryover, which is nothing but 1, or this is actually 10, which we give it a carryover. Okay. That is why you give 1 as carryover. So what happens now? Because you have given 1 as carryover, you have written. And what is this 2? This 2 is nothing but 8 plus 4, 12 minus 10. What was this 10? My base. Right? And whatever is the remaining, you write it here. Okay. 12 minus base, which is 10, you write it here, and you give 1 as carryover, or you give 10 as carryover. And what is this? Again, 7 plus 3, 9 plus 1, 10. Again, you got 10. So 10 minus 10, what you will write? 0. You will again give 10 as carryover. 6 plus 2, 8 plus 1, 9. Okay, 9 is accepted. 5 plus 1, 6. This is how you add when we deal with base 10. Suppose if you want to add in base 6, then what you will do? See this question. This one. 2, 3, 4, 5, 1. Adding it to 3, 2, 1, 4, 5. Try this question, guys. Tell me the answer. Just add this question in base 6. These both are in base 6. Add these questions. Simple addition. Nice. So I think you have got the concept now. 5 plus 6 is 5 plus 1 is what? 6. Can I have 6 in base 6? No. Okay. So what this will be? 6 minus 6, which is my base, which is 0. Okay. And what I will carry over? I will again give this a carryover. So okay, Priyam, you have done a mistake here. But how 6 can come, Priyam? First of all, let's wait. How 6 can come, Priyam? Because this is base 6, right? Can you have 6 in base 6? Just try it out again, Priyam. Just try it once more. Okay. Again, one carryover. 5 plus 4, 9 plus 1, 10, right? So 10 minus 6, 4. Again, one carryover. 4 plus 1, 5 plus 1, 6. But you cannot have 6. Again, 0 and 1 carryover. 3 plus 2, 5 plus 1, 6. Again, you cannot have 6. 3 plus 2, 5 plus 1, 6. So that this becomes 1, 0. Why 1, 0? 6 minus 6, 0. And this 1 comes here. So this will be your answer. 1, 0, 0, 0, 4, 0. Cool. Now similarly do the subtraction part. Subtract this from this. Tell me what is the answer. This is simple addition. If there is any doubt in this addition, then let me know. And this is subtraction. Just subtract these two numbers. And don't make silly mistakes in subtraction as well. Just take this analogous to your simple base 10. That how you would have subtracted in base 10. Okay, so I think everyone, you would have got this. Okay. Any issues in subtracting? I hope not. This is simple addition subtraction. So quickly moving forward from this. Now let's discuss something interesting. See, in base system, okay, in this base system, I'll teach you 2-3 formulas. Okay, there are again n number of formulas, but again not required. I'll teach you some 2-3 formulas or tricks that you can learn. Everything, how we are getting these formulas, or how we are getting everything, we are just taking an analogy. We are taking analogy to base 10. That is how everything is derived in base system. Whatever thing you will see as a formula, the derivation of it comes from analogy to base 10. Cool. So let's see. The first thing is how to determine whether a number is even or odd. Okay. How to determine this, whether a number is even or odd. Repeat. What repeat? Subtraction नहीं हुआ. Okay. Bharat, चलो. What is 5 minus 1? 4. Is 4 accepted? Yes, 4 is accepted. What is 4 minus 5? Can you subtract 4 from 5, Bharat? No, na. What you will do in that case? Chalo, tell me what you would have done if this would have been a decimal system. What you would have done if this would have been a decimal system? Borrowed. Do the same thing here. Come on. Do the same, ditto same thing here. How much will you borrow? Can you borrow 10? There you borrow 10, right, Bharat? Can you borrow 10 here? You will borrow 6. So you make this 0, you have borrowed 6 from here, right? What is 6 plus 4? 10. What is 10 minus 5? 5, right? Now is this clear? Again, when you have borrowed 6, 0 plus 6 minus 4, 2. right? Again, you have borrowed 6, 4, 4, 2, 5, 4. Clear, Bharat? Okay. So what I was saying is how to determine whether a number is even or odd. So there is a rule. What is that rule? If base is even, okay, if the base is even, that is base 10, base 2, base 4, base 8, and so on, the number is even if the unit digit is even, and odd if unit digit is odd. How to visualize this? Again, base 10. In decimal system, what do you consider? Which number you consider as even? When unit digit is even, the number is even. When unit digit is odd, the number is odd. This is what you do in base 10, right, guys? This is what is simply written here. Okay, that if base is even, then which number is even, which number is odd. If base is odd, for example, base 3, base 5, base 7, and so on. If base is odd, so if sum of digits, if sum of digits is even, then number will be even. So if sum of digits will be odd, then number will be odd. Okay. Any doubt in this? If sum of digits is even, then number will be even. If sum of digits will be odd, then number will be odd. Cool. How can you remember this? This so you will anyways remember from base 10. To remember this, let's take a base of 3. Okay. Let's take this base 3. If I am writing a number, let's say 11, what will be this number in what decimal system? Tell me the value of this number in decimal system. What is this number in decimal system? This is base 3. I want to convert it to base 10. This will be 4, right? 1 into 3 to the power 0 plus 1 into 3 to the power 1. This will be 4. Cool. So what is 4? Even number. C. Sum of digits is what? Even. So number is even if sum of digits is even, and number is odd if sum of digits is odd. Okay. So that is how you can remember this when a number is even or odd. So tell me, 341 in base 19. Is this an even number? Is this this is an odd number? What is it? Even number or an odd number? 341 in base 19. What is the sum of digits? Sum of digits is even. Okay, base is odd, sum of digits is even, number is even. Cool. Again, the thing that someone was asking, what is the maximum 5-digit number in base 4? 33333. I hope this is clear. What is maximum 5-digit number in base 10? What do you write? 99999, because 9 is the highest possible thing. Similarly, in base 4, what you will write? 33333. Cool. Compare everything with base 10. You won't get any issues ever. Okay. Now, next thing, highest. Highest as in Bharat? Okay. Bharat, what is the highest 2-digit number, Bharat, in base 10? Which number is the highest 2-digit number in base 10? How you are getting 99? Because 9 is the highest possible number, highest number possible, and you are writing it 2 times, right? Similarly, in base 4, which is the highest number possible? 3. Cool. Now, there is a formula that maximum decimal value of an n-digit number in base b is b to the power n minus 1, and smallest value is b to the power n minus 1. Okay. For example, if you want to calculate the smallest 4-digit number, okay, the smallest 4-digit number, what is the smallest 4-digit number? And suppose largest 4-digit number, this will be 10 cube, this will be 10 to the power 4 minus 1. If I tell you write down the smallest 4-digit number, smallest, what you will write? 1000. This is the smallest 4-digit number, right? And asking you to write the largest 4-digit number, what you will write? You will write 9999. What is this? Is this 10 to the power 4 minus 1? Is this 10 cube? Clear? Is this clear? That if in base 10, if I want to write smallest 4-digit number and largest 4-digit number, then I will write it something like this. Similarly, in base B, if I want to write the highest number, this will be what? B to the power n minus 1. See, B to the power n minus 1. right? And b to the power n minus 1. Clear? I'm just replacing base 10 by base p. I hope there is no doubt. Like suppose there's a question that largest 7-digit number in base 3 is decimal of it. What will be that number? Tell me. Largest 7-digit number in base 3. I'm asking the decimal value of that number. What will be the decimal value? No, cool, guys. That is fine. That will be 2222. But what will be the decimal value of that number? I've just now told you that if you want to get the largest number, largest 7-digit number in base 3, so what you will do? You will take, what is the base here? B. Let this base be B. Okay. What is the maximum value? B to the power n. Right? What is the value of n? With Arpit, will it be okay? Ayush and Arpit, both of you tell me. I'm just simply applying this formula, right? What should I write here? 3 to the power 7 minus 1 or 3 to the power 6 minus 1? What should be written? Everyone, I'm just applying this formula. Why you are making these mistakes? This will be 3 to the power 7 minus 1. Array, oh, what is n? N is largest 7-digit number, na? So this will be 3 to the power 7 minus 1 Priyam. Simply. Largest 3 to the power 7 minus 1. And smallest it will be 3 to the power 6. Clear? This is the decimal answer. The one that you are telling me, that is the base wala answer. Okay. This is the decimal. 3 to the power 7 minus 1. And this is 3 to the power 6. Clear, guys? That's okay. So this is a very simple formula. How it is coming? It is coming with comparison to base 10. Okay. Tell me the answer of this question. Which of the following cannot be prime in any base? Exactly. We don't know the concept of prime numbers in other bases, right, Bharat? But what do you know? I know when a number is even and when a number is odd. Try to use that. Good. Okay. Others? Guys, can an even number be a prime number? No, right? An even number cannot be a prime number. This number is even in even basis. This number is even in even basis, right? So these two numbers are even in even basis. Am I right, guys? So these two numbers cannot be prime. This cannot be prime in even base. This cannot be prime in even base, right? So let's check about the odd base. If base is odd, what this number will be? 3 plus 4, 7 plus 2, 9. Base is odd, sum is odd, this number will be odd. If this number is odd, it can be prime, right? But what about this? This is 10. If base is odd, sum is 10, again this number is even. So is 172 even anyhow, whether the base is even or base is odd? 172 will always be an even number. Is it correct? 172 will always be an even number. Ayush, about 324. Suppose base is odd. What is the sum? 9 is the sum, right? Base is odd, sum is odd. This can be an odd number. Clear? Similar with this, if base is odd, again this number can be odd in both even and odd bases. Any doubt in this? Anyone? See, 172 will be even anyhow, whether the base is even or whether the base will be odd. And that is why it cannot be prime. Any doubts? Anyone in this? Guys, clear? Simple even odd concept in basis? Cool. Okay, tell me the answer of this question. Again, do one thing. Forget this is base 3. Suppose this would have been base 10. What you would have done? Tell me. If this would have been base 10, unit digit mein what you would have done? 17 mod 10, right? So here what you will do? 17 mod. What is the base? 3. This is your answer. If this would have been base 10, you would have taken the remainder with 10. If this is base 3, you will take the remainder with 3. Obviously, answer is 2. Any doubt in this? I have told you whatever concepts we will discuss in base system, it comes from direct analogy from base 10. Okay. Next question. Find the last two digits of this in base 4. 16, 16, 16. You will take square, right? You will take square. There you took 10 square. Here what you will take? 4 square. Simple question is this mod 16. That is the simple question. What is 16 threes are 48. This is -1. Answer is -1 or 15. Clear? Next question. Number of trailing zeros in 100 factorial. What is the answer? How you will do this question? We have done this, right? 100 divided by 5. Number of trailing zeros. Yeah, last class only. Yes, correct. So this will be what? 20 divided by 5, 4, 4 divided by 5, 0. So answer is 24. Cool. Now let's take it to base system. Number of trailing zeros in base 21. What will be the answer? Again, follow the same analogy. Just follow the same analogy. Yeah, greatest integer function, right, Bharat? Use the same analogy, guys. Ditto same analogy. What will you get? If this would have been base 10, what you would have done? 2 into 5, and then you would have taken the greatest integer with 5. This is base 21. Now what you will do? What you will do? 124 factorial upon 7 plus 7 square plus 7 cube. Just I've broken 21 into 7 into 3, and I've taken this. I should ideally take off 3 also, but it is clear that here 3 will exceed 7. Hence I've just taken off 7. Answer is 19. Okay, one more question. Solve 100 factorial in base 24. Number of trailing zeros. And why we are doing this, by the way, just question why we are doing this, because this is base 21, right? So who will make 0 here? See, what is the concept behind this? Who will, in base 10, who was making 0? 10 was making 0. In base 21, who will make 0? 21 will make 0. That is why I'm dividing it by 7 into 3. 7 into 3 will make 0. Okay, now let's move to base 24. What will be the answer to this question? Bharat, we have to divide it into prime, right? So 3 into 2 cube you will divide it, right, Bharat? You will divide it into 3 into 8. Or 3 into 8, so hence you will get 3 and 2. This is one question. Because here you cannot simply rely on this 3. You guys asked me, right, sir, in which question we cannot simply rely on this bigger number. Although 3 is a bigger number, you cannot simply rely upon 3. Now suppose if I want to calculate upon 3, so 100 by 3, this is what? 33 plus 11 plus 3 plus 1. How I am doing this? I am just dividing it by 3 and all. Okay, this will be 48. So I will have 48 threes at hand. What about 2's? 100 divided by 2, 50, 25, 12, 6, 3 and 1, right? This is nothing but 97. I'm having 97 2's at hand, but because 3 2's are making 1 8, 3 2's are making 1 8, how many 8's I am having? 97 by 3, which is 32, right? Clear? Yes, Shashank. So this is one question where you cannot simply take out the value of 3 and answer it. Cool? You have to take out the value of 2 also. Why? Because we are seeing that there is a cube here. So 3 2's will be required. Answer is 32. Chalo, let's move to the next concept. Okay, guys, I'll just tell you 2 formulas which is very important in base system for CAT. So again, we are getting this by an analogy to base 10 only. The first one is sum of digits of a number n in base b is divisible by b minus 1. Okay, if this is the case, then it indicates that n in base 10 is divisible by b minus 1. What is the meaning of it? See, again we will correlate with base 10 and divisibility of 9. The correlation, everything that we will do in base system, you will get the correlation with base 10 only. Okay, let's take it with an example. This number in base 3, this is a number in base 3. Okay, this is a number in base 3. So let me write it also. 2121121. This is in base 3. What is the sum of digits of this number? 3, 4, 5, 6, 7, 8. Sum of digits is 8. Okay. If this sum of digits is divisible by b minus 1, this is my base b, right? So if this sum of digits is divisible by 2, is this divisible by 2? Yes. So this condition is getting satisfied, that sum of digits is getting divisible by 2. If you remember, what is the divisibility of 9, guys? 9 divisibility kya hoti? Suppose there is a number 1, 2, 3, 4. If sum of digits is divisible by 9, then that number is divisible by 9. Correct? This is what we used to say, that if sum of digits is divisible by 9, the number is divisible by 9. From where this divisibility was coming, I was writing this number as 1 into 10 to the power 4 plus 2 into 10 cube and so on. And because this was 10 divided by 9 is 1, so this will be simply sum of digits. So if this is base 3, how will I write this number in base 3? 1, if I want to convert it, I will write this as 1 into 3 to the power 0, 1, 2, 3, 4, 5, 6, 3 to the power 6 plus 2 into 3 to the power 5 and so on. Now, if the sum, again, if I want to check the divisibility by 2, then what will happen? This all will become 1. This will come out to be sum of digits. So same thing is happening. If sum of digits is divisible by b minus 1, then what it indicates that in base 10, this number is divisible by b minus 1. So if I will convert this number to base 10, then this number will be divisible by b minus 1. This is the indication of this. Okay, so everything is just an analogy of base 10 only that we are discussing. Cool. So okay, so is this clear? First of all, we'll solve some questions on this as well, but is this clear as of now? The simple analogy, base 10 tha, so base 9 was sum of digits, base 3 hai, so base 2 is sum of digits, base 17 rahega, 16 will be sum of digits, just by analogy. Okay, so if this is the case, then it will indicate that n in base 10 is divisible by b minus 1. So n in base 10 will be divisible by 2. This is the indication. Clear? This was the first formula. What is the second formula? Here what is happening? See, I'm checking, this was my base b, and I'm checking the divisibility by b minus 1. But what if base is less than but if base is less and divisor is more, then what will happen? Suppose the base is 8 and I want to check it by 9, then what will happen? See, what was the divisibility of, if this number in base 8 is divided by 9, okay, what will be the remainder? I want to know this. This is my question. What is the remainder when this number in base 8 is divided by 9? Again, this is analogous to saying that this number is in base 10 and I want to find mod 11. Like here we use an analogy 3, 2, 10, 9. Here I am again using an analogy 8, 9 to 10, 11. Cool. So I can simply apply the divisibility of 11 in this case. What is the divisibility of 11? Alternate plus and minus, right? So plus minus, you will do this, you will get the answer as 4. Without even lifting a pen and paper, you will say that the answer of this question is 4. Why? Analogy of base 10. Again, similarly here also, why? Analogy of base 10. So everything that we do in base system is an analogy of base 10. First of all, tell me, is this clear? We will solve few questions on it, but is this clear? How we are using analogy each and every time? Any doubts in this, that how we are using analogy? Anyone? Any doubt that how we are using analogy? Guys, is this analogy clear? Any doubt? Anyone in this analogy? No? Let's solve a question. 234 is in base 8. 234 is in base 8. I want to find mod 9. What will be the answer? What will be 234 mod 9? Good, excellent. I can just say that this is base 10 and I want to take out mod 11. Cool. plus minus plus. Answer is 3. This is as simple as that. So these are the two basic formulas that we widely use in base system. Okay, and you can get direct questions on it as well. Try this question now. 25883 base 17 mod 8. Guys, what have we learned as of now? I'm just giving you a hint for this. I have learned that this mod 16 I can correlate. But this is mod 8. How can I do this? Just apply your brains. Try to solve this. We have seen in case of if there is a difference of 1 on either of the sides, lower side or upper side, then so it is fine. But what if this is 8? How can we do this? Just try it out. Okay guys, in base 17, right, what is the divisibility of 16? In base 10, what is the divisibility of 9? Sum of digits, right? So in base 17, what I can determine, if I'm having base 17, I can determine either the divisibility of 16 or I can determine the divisibility of 18, right? So what will the divisibility of 16? Divisibility of 16 will be sum of digits. Simple analogy. Everyone pay attention. What is the sum of digits here? Just add it. 10 plus 8, 18, 18 plus 8, 26. The sum of digits is 26. Okay. So I can say that what is my remainder with 16? If I'm dividing this number by 16, then this is my remainder. I can say 26 is the remainder, or I can say 26 by 16, which is 10 is the remainder. I can say this, right? If I am dividing this number by 16, the remainder is 26. So what is the remainder in this case? 10. But am I dividing this number by 16 or I am dividing this number by 8? I am dividing this number by 8. Okay. So what will be the answer? 26 was my remainder, right? 26 divided by 8. Simple, answer is 2. Or you can also say 10 was my remainder. 10 divided by 8, answer is 2. Clear? I'm using simple analogy that if this would have been base 10, then 9 का क्या होता? Sum of digits. This is base 17, so 16 का क्या होगा? Sum of digits. Clear? Sum of digits should be divisible by what? Sum of digits will give me the remainder. What is the sum of digits? 26. So 26 is the remainder when this number is divisible by 16. Or I can also say remainder is 10. It won't matter. So if this number is divisible by 8, what will the remainder? 10 mod 8, answer is 2. Clear everyone? Any doubts in this? Anyone? Everything in base system, explain. Okay. Chalo, let's take this one more time. Okay, Sashank, tell me, ये question भूल जाओ. Suppose this would have been base 10. This would have been mod 9. What you would have done? What would have been the answer? Sashank? Summation of digits. So this will also be summation of digits, Sashank. Mod 16 will be summation of digits, right, Sashank? This will be 26, Sashank, right? Or you can also say, you can say that the remainder is 26, na? Or you can also say that the remainder is 10. Cool. So, but we are not asking this 16. What we are asking is 8. So what will be the answer with 8? 2. So I hope this is clear that this is how you use analogy to solve any question of base system. Okay. So I hope I made this easy for you, although it is a bit complex, but I hope I made it easy for you. Few things I have skipped deliberately. I've skipped few things that we might cover in advanced number system if you guys are willing to and if it is needed, because I haven't seen a question lately. In 5 to 10 years, there was no question from this section, advanced number system, with the topics that I cover in advanced number system. So that is why it is till now only number system would have become somewhat hectic for you. So that's why I do not want to just barge in few more things, few more formula based things or few more concepts on this. If just go through the mocks, try to solve the mocks, okay? And if there is any doubt, then let me know. Cool. There are many topics, Priyam. See, actually what happens is in this thing, we cover various topics. The topics that we have discussed as of now, we take it to one notch higher, right? That's why. Okay. Veer, you can tell this thing to Shubham. So Shubham can arrange, because see, I have taught you this subject, right? So it would be best if someone else like Shubham, he can give you 10 to 20 questions in the group, or he can also take a session in the group and he will give you some questions to solve. Because if I have, he will give you some different questions. Suppose if there is any question of any type that you are unable to solve, then we can take that over. If I will give you some questions, then again it will be somewhat biased. So it's better that Shubham or Sham sir is doing this. So just ask Shubham if he can do this. Cool. Veer, just have a word with Shubham that whether he can give you some questions on it. Anyways, assignment will be given. But regarding session, let Shubham give 10 to 20 questions on the group, or you guys can also contribute questions on the group. In this way, you will have some good practice. So yeah, regarding ANS in binary system also, the system that we have seen today, there are certain things like number of digits calculate karna. What will be the number of times digit 2 is repeated in 1, 2, 3, 4 base, let's say 6. How many times 2 is repeated? This is one thing. This is just one thing. So in this way, for each and every section, we take it to the next level in advance. But this is not needed because I'm not seeing any questions lately. And you won't get a question, trust me. The level of cat that I'm seeing right now is not that it will test on these lines. It is not possible. The things that we have discussed, this should be more than sufficient. The only fear is, because of which I'm not discussing these things, is if I will discuss these things, then you might get confused with the basics, because there are a lot of complexities involved. That is why, trust me, in CAT you won't face any issues. It might happen that in AIM CATs or some, not even not in IMS or any other mocks, just in AIM CATs, it might happen that they might give you few questions on this. But you will solve each and every question by the concepts that we have discussed. Now go and practice out the questions, okay, and make sure that you are scoring high and efficiently in number system as well, like you did in this arithmetic. Okay. SCF and LCM, that we will do. That is basic only. That we will do. Don't worry. Okay. SCF and LCM, that we will cover. SCF already we have done in SCF, but LCM somehow I forgot. So that we will do. SCF and LCM model. So in the next class, we will cover SCF and LCM. Mukul, number system cannot be confined. Okay. This topic cannot be confined. There are n number of concepts in number system. In fact, I can take, say, 2-3 more classes on number system. So there are so many concepts in number system, but it is not at all required. Fine. Yeah. So with LCM, NS class will be over. Just solve the questions. If there is any doubt in any question, then tell me. Any doubt in any question. Because number system cannot be confined, that is why I'm doing this. Log is not a part of number system. Okay. Log you will cover as a part of algebra only. Fine. Yeah. So after this, what I'm planning to do is, after this, let's start PNC and probability. Okay. Let's finish these two topics. I will also probably take Venn diagram. I will probably take Venn diagram also. And this will be a really interesting topic for you. Trust me. This is going to be a really, really interesting topic, Venn diagram. This will be basically a part of LR, okay, of DILR. And I might also take one more topic in DILR. Let's see. Fine. So I will take PNC probability. Yeah. So Shweta, the topics that can guarantee marks are arithmetic that we have discussed. You cannot go wrong in that. Number system, if you're clear with these concepts, you will definitely score high in that. I'll make sure that PNC and probability I'm covering in a good fashion, because they are interesting topics. Okay. Yeah, don't worry. I'll try to have a unique approach in PNC, and there are again few formulas that I have derived. So I've again tell you those formulas as well, so that you can solve questions within seconds in PNC also. Okay. Functions, this is a part of algebra, Mukul. Right now, see, guys, where are we right now? We have covered arithmetic. Okay. We have covered number system. What is remaining? Remaining is algebra. Remaining is geometry. Remaining is modern maths. Okay. Next, what we are starting is modern maths ka PNC and probability. Right? This we are starting. Post this, what will happen? You will cover algebra, where you will cover each and everything that you have written just now, sequence series and everything. Regarding Venn diagram, see again I have a very holistic approach on Venn diagram. We will cover each and everything in Venn diagram. Don't you worry. Whatever there is, we will cover. Fine. Yeah, geometry is also there, Shweta. See, mostly what happens, arithmetic is the largest section. Okay. Priyam geometry Shyam sir will take. Okay. Geometry this will be taken by Shyam sir. Fine. Algebra bhi mostly I won't take. Shubham will take algebra. As per the plan as of now, Shubham will be taking algebra. Veer, possible hai, but don't you think you guys will be loaded? Because anyhow, right now you are having 6 classes a week, right, Veer? Won't you guys be loaded? Like 2 cons, 2 DILR, and 1 VARC you are having. Suppose if we start geometry right now, let's say, then won't you feel any load? No, we cannot do this ki DILR hi chhod do. Are? How can you leave DILR for a month? No, you cannot do this. That how can you leave DILR for a month? That is not feasible, right? Anyways, I will take Venn diagram also and PNC probability also. Apart from that, let's see. Earlier, I was planning to take algebra, but now Shubham will take algebra, and I will take these 2 topics. Cool. Yeah, DILR is something like that it requires lots and lots of practice. DILR is something like that. Chalo, good night everyone. So this marks the end of number system. We will discuss LCM model. Priyam, just do one thing. Just remind me tomorrow or the day after, right? Just remind me once that we have to cover LCM model. Just do this one thing. Okay. And in the next class, we will discuss LCM model, and then we will quickly start PNC. Okay, chalo, good night guys. Have a nice day. Next class, we are taking Venn diagram. Post that, we will cover PNC probability. Fine. Good night everyone. Take care. Good night.